Well, I'm back. Took a while to fix stream. I don't know, something was not working. Anyways, hello, I'm Zinc. And this is engineering. Yes. If I plop out of this. So, the thing is, if I zoom in into my engineering cam, how do you do this again? Yeah, if I zoom into my engineering cam, which is this bit higher, I have a thing which I made. I made a short on it. Currently looks awful. Previous version definitely looked better. And it's basically a glow stick. But wait, there's more. There's also a motion sensor, so you can actually use it as a glow stick and as a drumstick. Yeah, I will be highlighting this probably later, or not. Probably not. But yeah, I have a glow stick which I can configure, and it's very nice looking thing. And this is small, so everything is outside. Eventually we'll be planning to move it to miniaturize, basically use all of the modules and put it into one single PCB. Maybe in LEDs, maybe. So it could actually fit in this kind of size. Currently it does not. That's why I printed a bigger stick. It's like about 40 centimeters. Basically double the size. Yeah, a big stick. And yeah, I'll be designing so every component would fit into the stick. In that way, you could actually test out all of the functionalities without this jank, focus on the implementation, maybe add an additional user buttons, and then I can miniaturize. So never optimize before I actually do other things. Why my avatar does not want to have... Wait a minute, I need to restart thingies. Oh, good, start. Good, now it will track my audio too. Reset. So that's engineering cam. So we reduce the cam. I will also be replacing the battery for higher capacity. Current one is just from a vape. It's small. It's very small. Okay. I will be combining multiple components though. So for now, let's switch to printing. I need to start the print. Hopefully it will be fine. Which one is it? Onshape hide. So we have our printer. Downloads. Already have module downloaded from before. We'll see if I can actually print it out in the meantime. Move it a bit up. This area for me, it's very have sport stickiness. Look at this. It has such a fancy layout and a place for mounting the PCB and mounting itself too. 0.4, 0.2, 3. Let's see if I have enough clearance. That looks like barely enough clearance. Yeah, I mean, may need to scale it a bit up. I'm printing with 0.8mm nozzle, so that's probably a good idea. Floating cantilever. Scale it up. Guess by 5%. Be 40 minutes to print. That's quite a long time. But at least the clearances now look better. We'll see. That works. I still have power components to actually design and print. Transfer. Make a layout. Print, upload and print. Interesting. So the print should be starting in some time. Hopefully. In the meantime, let's actually start designing stuff. How do I import our components? Or do I need to make an assembly? Can pause my engineering camera. Currently it's not necessary. Oh wait. I forgot about the very important thing. It's charging my phone. Yeah, I was looking for a charger. Back. Good. I guess first design a tube. Tube. Sure, that will be probably easiest. Sketch on top plane. Do the top circle. Use a caliper. Because my caliper's battery is almost out. Well, it is out. It's 35.2 millimeters outer diameter. Dimension 35.2 outer. millimeter. And about 1.1 millimeter thick. So the distance between this one and this one is 1.1. So that is my tube. That is my tube, and my tube length. Kind of difficult when it's so far away. We have a tube, and I will measure it. It is 38. Well, 39.8. It's through this one. 398. It's a tube. So that is a tube. Yeah. That is a tube. Just press this one. Good. Oh look, print has started. Okay, it seems to be sticking, which is fine. I wish I could have camera closer, but my camera is very jank. I can't. It does not zoom either. Wait. It does zoom, but not in the way you think. Transform. Add to transform. Can increase the scale by twice. Can I increase the scale together? Beautiful. Amazing first layer. 1/400 and 840. And then if I crop some stuff more, 500, 500, 500. Yes, look at this beauty. I can probably crop top too. I even increase the scale even more. Yeah. Oh, that did not help at all. Sure, let's just go like this. It's printing. Print cam. We'll see if it's good enough, or at least it will give me a reference to some extent. Tube. I have the tube. The tube will need a platform. Yeah, I'm planning to use these kind of rails for the LED strips. Rails. How do you... That's a tube. Tube needs what? Tube needs rails. I do need keyboard, but now currently is in the way. Mouse to the side. If I move the keyboard to the side, move the camera closer. Move this cable up. This cable up here. Oh, that's better. So let's take it out. Let's take it off. Reveal the beauty. Why is it so hot in here? That is my button. That is my tube, and the tube inside has a LED strip. It's kind of difficult because my hands look very far away. Duct tape. Okay, print is going nice, which is nice. Good. So we just take out this tiny tube, big tube, or big tube and tiny tube. It's not. The difference is quite significant. So that's my tiny tube. That is my big tube. So the plan is to fit the... We're just lacking field of view, very likely. The plan is to fit these components like this, which is surprisingly almost the right size. So we have a rail, which is, I guess, the same size, about 20. A button, which is currently very messy. We have our button. Do not roll for me. And our controller and stuff. Oh, I actually can see how well it actually distributes lights. And that is quite good. Yeah, that's way better than the smaller one, which you look at that, it's overexposed even. It looks fine on not on camera. Yeah, so it would be amazing if it would be like glowing throughout through all of the length, but not at this stage, because designing it for it to be in that kind of manner is quite difficult. Because I have a battery. A battery is thick. So at best it would need to be like this, a sandwich. So I guess would kind of work. Whoops. I pressed the button with the... So a sandwich like this, it's not great. So I guess, yeah, maybe just leave it like this. This one is 18, so need to somehow make it to 20. Sure. Yeah, I guess start with a simpler part, which is just rails. Up 20 millimeters. 20? I do need some clearance for the back. Or not. Phone, shut up. I'm doing what you think. Quality. Can play shadows. So, instead of it being like this, where the battery is on the back, we're gonna have the battery in the front. That's quite a lot of space. Okay. Yeah, I guess start with rails. That would be easier. All of this. Rails, rails, rails. What about end caps? sure. Sketch on the surface, top rails. Configuration panel. Can I add a not really custom tables? Nope. Variables. Print clearance. And clearance. And it will be how much? 0.2. I think it probably should be 0.3. So I can reuse that one. Another thing would be rail length. Rail length, let's say 20. And maybe I'll be making the caps little caps rather than inner features. 200. Oh, I need more. Would be insert full. This one would be 3.95 and insert height full, and then screw full is 3.5. Parameters, very useful. What I'm thinking I need to have two pieces together. Or can I make it a single piece? Could probably make it a single piece. No. So, very simple shape. Basically, we start from here, go like this, we go up, go 45 degrees. Yeah, that's how I did it. Kinda. $45. A bit up, so it would have some meat on it. To the side. Because there should be an arc in here. And to the bottom. Yep, that's and here. And that's the thing. Escape line. And then you get the circle. Circle to this location. Then I can escape the circle, delete this line, delete. guess delete this point too. Delete this one too. Yeah. Is a millimeter enough? Probably even less. It's more like about the clearance. Okay. I know the dimensions of this one. Hi Dan. Okay. I hope the I hope the printer is not too loud though. It may be a bit too loud, but that's how it goes, I guess. It's a machine. So, okay. I can see the dimensions. My LED strip is very small actually. It's only 10, 10, 10, 10, 10. So it would be 10 divided by 2 plus clearance. Yep, we can reuse the inputs. Of course I can't just do that, can I? 5 plus clearance. Why cannot? What? Okay. In Fusion you at least could do the math on the parameter. Or do you need to add additional parameter? LD strip half of this. Half of 5.3. Sure. And then the distance between the circles should be the clearance. Okay. Height parameters. This height should be probably millimeter. Just plenty for LED strip. Even the thicker ones should work. You see the print is going. It would be amazing if I could design it faster. Well, that's a battery test print. I may actually have a cap test print. Maybe. This. Wow. That's a glow stick. This one. Tolerance options. I hate that option, but it should be notified then. And the length. Let's say 2. Just to be safe. So it would not be just flopping about. This could be a single millimeter too. Create a point. Okay, we created the point and now we trim it. Trim the outer circle. Okay. Distance dimension on this one width. Probably half a millimeter. 0.8. 2 layers. 1.2. Multiplicative of my layer height. But you see, wait, I'm thinking. This is wasted material, but is it wasted material? It is a wasted material. It would give me a bit more weight in it, and having a cutout would probably help. No, I don't want to. I don't want to have extra retractions. Retractions are difficult to print, generally. Especially when you have 0.8 nozzle. My printer in this blue lit environment looks kind of like some kind of spider. Yes. So that will be the profile of a rail, which is simply sliding. And the end of the profiles could have a hole for a screw, which would hold a cap. If the profile goes along the full length, yeah, I can use the screws to just have a cap at the end. And if all the assembly tries to go to that direction, the cap will stop it. If it goes to another direction, the other side of the cap will stop it. Yeah, that sounds quite good. Now, circular pattern. No, it's a mirror. Can I make a circular pattern of it? Probably not. It's a mirror. Mirror line across this. Just copy these. And now it's mirrored. Undo. Press again. Now this. We select all of this. And now it's mirrored. We have a bridge, but I don't think it's a problematic with this kind of size bridge. I can always, if I lack quality or something goes bad, we can just split it in half and be okay. Okay still. So this is a rail. Let's rename it rail. And rail needs to be extruded. And extrude. Our direction. Rail length. Rail length or tube length? Could have like the tube length and modified the rail to have right kind of, I guess, cutouts. Yeah. Yes. Let's make it throughout, so don't need to edit the profile. And that's a rail. Let's rename the parts. The tube. the rail. A tube and a rail. That is okay. The tube and the rail. Okay. Could probably design the mounting holes for the end caps. Yeah. So that's a new sketch. Makes it a bit simpler to do them. A simple circle. Wait, I don't have a projection for some reason. Reference. No, project. Project. I don't remember. Sketch. Linear pattern, search construction. I don't remember. Oh, it's still like not snapped it. That was a nasty sound. Very simple. And then I draw a line, make it construction. Q. Okay. Now not the construction, circle. Dimension of a circle and another circle. The dimension of a screw hole. And this one will be 12.5. Okay, that's not good. 11 millimeters or whatever. Somewhere in the middle. Sounds pretty good. Look, my print is almost finished. It's like 5 minutes left on the print. There. I can enable symmetry. Now I just need to press mirror. Good. Good. Okay, and now we extrude all of this. all of this. And wait, there's more. All of this just needs to be smaller. And it's not 25, that's an overkill. That's maybe 3 millimeters, maybe. Is relatively should be small. Yeah. 3? Make it 5? So I could add a insert. Because if we look at a screw, where's my camera? It's a screw. I want the head of the screw to actually go inside. The head of the screw is what size? 3 millimeters. Yeah, so having 5 probably is good enough. 5. Kinda looks like a fluorescent light tube. Kinda is, you know. So that's this part. Let's rename this step of app. That's good. Let's show the sketch and make example. Extrude. I will be extruding solid. And hold size the opposite direction. Pulling geometry middle. Oh, it should be removed. And what kind of screws do I have? Yeah, I have a bunch of these are very big. Oh yeah, these are smaller. Why do I have way too many screws? Oh look, it's a PCB I mean. Ten? Probably 10. Yeah, sure, let's just pick 10 centimeter. Likely could be smaller holes, but that's fine. You need to have some clearance for the plastic to run out because it's not refillable. And this one. And this one. Good. Can I make it symmetric? Symmetric. Oh, my print is just completed. Good. That is fairly quick. So I'll be able to make another print, which is a cap. Okay. So that's a hole for these. Because I cannot print this one in one go because my printer is too small. But print. Let's go back to engineering camera. So the print has been completed. It's a thing for the battery. That's supposed to happen. Yeah, it's very good that they increase the clearances, because otherwise it would just binding up. So we have a spring. Wait, why is it? Shouldn't be opposite sides of spring? Oh wait. First of all, engineering camera. And that's the other one. Engineering camera. Take your battery, we plop it in, and it just snaps in. It's not super tough. I guess if I add things in here, it would be better. Originally, I think about just adding some screws like this. Yeah. Oh wait, if I use a heat insert into this place, and then bind the screw like this, and then do this, we have a battery terminal, which then wrap around the wire, or solder wire, and holds. And we have a place for a charger. Why is it? It's likely something missing in this place. But all this assembly then could go into the tube. Yeah, all this assembly nicely fits into the tube. Oops. Yeah, it's in the tube. With plenty of clearance left. So I'm pretty glad I actually printed the slightly larger tube. Even though this one could fit the battery, I would need to redesign the battery holding system, which is annoying. Especially if you want to quick swap it. Quick swap the battery. In that case, if I had the tube of like having some fancy mechanism which just look remove the cap faster would be nice. But they don't. So that's a battery. That is a battery with this engineering cam size. It's not needed anymore. That is a battery and that's a tube. And that is a cap. Let's print a cap. But for the cap I need to have some holes. Never mind. I need to make a sketch first. Simple. Circle. Dimension. It's about 6.1 millimeters. Surprisingly, that's actually like this. And mirror line. Don't have mirror lines. Instruction. It's a mirror line. Mirror. This one. Okay. camper board. Extrude this one, remove one. And this is the cap. But wait, cap needs to be smoothed out because users. So we add a chamfer. And we don't need chamfer for it inside. Okay, and rename it. Rename the cap. Export it. Export as a Art Studio 1 cap, sure, whatever. Options. Sure, export. Where's my project folder? Where's my Glowstick project? Where did I put it? Glowstick. Be right back. I need to go quick for a bathroom break. PP50, it's here. Again, the cap should have been downloaded. Oh no, it's asking where to save it. Projects. Sure, just make here. Glowstick. Oh, because I use a different model. Okay. File in the project. For transfer. Add the file. Oh wait, I did not get it yet. Uploaded successfully. No, export completed. Me 14. Is today 14? No, it's not. the menu. Hey, why you did not export the part? Export. Part Studio. Export. Notification of its status. Yeah? Why isn't it exporting? Ah. Where did the download then? Something is not working about the export to me. The other end will also need to have a hole for a button and a hole for a USB-C, yeah, for charging. Cheap mother. Why is it not exporting? Part Studio export completed. That's not the right thing. I don't understand this. Why is it not exporting correctly? Cap. Options on. Now. Oh. I'm just blind. That's why. Come on. Fights? Technical difficulties. Bonk. If I turned off the lights. Why are you now exporting? Okay, that. It did export. Switcheroo to the Orca. A very simple part. You could say, oh, we need two. No, currently we just need one to just see how it looks like, how it behaves. Because that side of it is going to be like that, and it's just quick 11-minute print. Okay, print is starting. So that is a cap. Okay. Let's see cap. Goes on. The cap is completed and we have a rail. I guess now we need other side of the cap. And should I be switching the battery side? If we switch the battery side, I will not be able to charge it without turning it on, which is not a good design decision. Okay, back to Onshape. Fit this. Fit this. I guess I just need to model the square of it. Of the battery. So yeah, idea. I print this. Well, I have it printed. It has a single mounting hole. Could be used. Oh, it's even perfect. A single mounting hole. And my light switch. Spider looks like it's kinda does the same thing, but I guess less than Blender. It's Onshape. It's just basically 3D modeling. Whee! And it's web browser based. So what's up with my light source? It's very badly oriented. Yeah, an emote. So idea is I can use this screw to bind it here. That's probably going to work. Though I may have problems with the button. Or you know what's even better? To not need to model all of this, I can just import the parts somehow. I don't remember how to do that on Onshape. Can I add the parts? The part studio. Create part, create assembly. Assembly could. Wait, what? How does that work? Can create an assembly. Or can I create a derived part? Maybe derived part? Derived. Using an associative link, insert parts, sketches, surfaces, planes, or matte connectors from one part studio into another. I think so. And that literally, okay, select part studio. Other documents. Decent. No. glow stick. Yeah, parts. So insert the part. This. It doesn't matter. But create a version. I guess it needs to be assembly. That's an assembly. That's a part. That is an assembly. Create new folder. Insert. Oh, look, my printer is running. Definitely need to increase the size of it. How do you zoom in? Zoom in more. Maybe a bit less. Move it down here. And then do some cropping probably. Print cam. Transform at the transform. 50 or 450. Close, print cam label, print cam. Engineering cam is here. Yeah, printer is printing. Good. What was I doing? Oh, trying to assemble some parts. Can I do? Okay, first insert all. What? It snapped. Okay. Other documents. Recently opened. Nope. Created by me. This one. It doesn't count, but I can insert in this model. It's just terrible, terrible model. Charger. Yeah, that's not going to work, will it? Probably not. I think I just do a very simple thing of just dumb modeling, which is measure a part and just fit it. So in that case, I need a part. Of course, I need a part which would represent the battery case. Clickety bottom battery case. As it's a part, I can hide others. Don't need that. And our battery is very simple. Very simple. It's a box, literally just a fancy box. Would even have some holes for wires. Nice. Yep. Very simple box of 24 dimensions. 4. And the height is what? Well, I'm not using a caliper. 22. Height is 22 millimeters. Very simple. It's just a box. Adjustable box. And the cap is almost done. Oh, nice. I don't think it needs anything else from it. Not really. Extrude. And its width is what? Sand check. Yeah. 133. 13 centimeters, that's quite a lot. Yeah, you see how much space just the battery takes. It's one of the biggest parts. So that's the battery part. Well, I also probably should have the holes for them ready. Probably. Yeah. I wish I had snacks. I don't. I have a bunch of peanuts, but like they're just small. Print completed. The bed is still a bit hot, so we'll have to wait to take it off. So create a sketch on top. One sketch is for this part. I'm thinking of opening an engineering camera should be in here. Slightly higher print cam can be nice smaller because nothing is printing. Yeah. Something like that. So this cutout will hold a charger. For example, that's not the same charger, but that's a charger. Yeah, we have a charging chip. Yeah, this is a charging chip. Well, should be, but in principle it just stays somewhere around on this place, and it should be touching the USB-C part, should be pointing out of the cap. Yeah. Drive can I need another window to look something up. This one, new window, and Onshape. object geometry. Oh, it's use. Okay, that makes more sense. It's use command. So we have use command, which makes a reference to our object. That is the wrong kind of rectangle. Draw a rectangle. Make a dimension. And that dimension is what? Yeah, I guess it does not matter. Just make it to this location. 54 millimeters. Okay, 54. Our mounting holes to mounting hole here, mounting hole in here. Dimension. Screw the hole. Screw the hole. Distance between the points. This one and this one point. That's construction in dimension. And this point and this point should be what? Why is it not 10? Seriously? That is one bad design. Or it's actually inches. Is it inches? Why? Why? Yeah, it's 4 inches. Why? Why it decided to be 4 inches? Like, seriously. Metric all the way. If you use metric screws, why use inches? It's 12 and a half. This is dumb. Wait, that does not look right. Oh yeah, of course it does not, because I measured distance between the holes and not the distance from the hole, from the edge. 20. What? What? I really cannot measure. It's 20 from the edge, and yet it's 12 and a half. That did not look right. The whole square is not right dimension. It's my caliper. I need to edit the previous sketch. This does not look okay. Okay, so that's the mounting holes. Edit the sketch. I will need to edit this extrude actually. Not this one, this extrude. Edit. It is. Oh, my brain is not working. Good. 14. Yeah. Why the hole is not here? Ah, I probably just mistyped it. Yeah. less, just a centimeter too much. Yep, that looks okay. Yeah, this looks okay. Good. We extrude. First we extrude the holes. I don't like the song. Next song, please. Depth. Sure. Show the sketch and again extrude. Shift E. Remove. How much do you need to remove? That's actually more difficult to answer. So the width of this 5.8 and 22. $16.2. Point. Not point. Okay. So that is my battery thingy, which I'll be able to mount. Let's check the part. I have this little puck. But only with focus. Yeah. It's a cap. So we take a cap and we place it on top and look at the seamless transition. And then we take a screw. That's the wrong screw. Take a screw and just like plop it in, and now it's flush. Yeah, pretty good. And we use heat inserts to mount it to the rail, which I still have not printed because I don't have it finished yet. Because the rail will be combined with this part and split into multiple pieces because I will not be able to print it in one go. As the largest thing I can print is 20 centimeters. Okay, so that's the thing. That is the thing. And that is a tube. And that is a rail. Surprisingly, I may not need to do much changes for it, because it's at the limit? That's not right. That does not look right. I have way more clearance than this. Or is the inner... Oh, my 2 dimensions not correct. From the cap I would say, well, from the cap they are correct. You know, measure twice, cut once. That's the square maybe looks too. Yeah, it is 33. So why is this looking... Oh, because it has chamfers, that's why. That is why it has more clearance. Chamfers. Yeah, these chamfers make it look that I have more clearance than I actually do. Yep, that is the case. Which is good. Still fairly easy to model. There may be an issue with the button itself. Because my button is quite big. It needs to fit quite snugly. Can't find the edge. I see another thing that I will need to print. A thing that holds the circuits. We have this teeny tiny bits here. Yeah, and I guess they're used to clamp on the board because the board, for some reason, does not have mounting holes. Okay, that is the battery thingy. Which takes quite a long distance. There's the end. A glow stick, soon to be disassembled. A glow stick which uses a battery from a weight. So that is my charging chip. Like how everything is neatly packed. Will I be able to fit everything? No, because I need to fit the button too. I definitely need to move my light source. I'm blocking my own view. So this can be moved to this side of the battery, so probably should disconnect the battery. Where's my snippers? Sparks. No sparks because safety. And look at this adorable little battery. This is from single-use vapes. And these batteries are fairly good. Like, they're just lithium-ion rechargeable batteries. It has 500 milliamp hours. Yeah, pretty good. I guess the issue for this kind of application. This one has 2000 or even more sometimes. So it's like, I guess the size is the same per watt. So take this off. Have ESP controller. I need a screwdriver. Might as well print this one. This one, drop it away. Yeah, all the circuits, a button, a bunch of other stuff. Not going to just fit just closely. Move the mouse to the side or leave it at a moment. And the charger. We have a USB controller. Just disconnect those. So I'm going to rewire everything anyways. Oh no, the project is being rewired. How could you do that? Can. Simply can. I will. The button. The button and the ground. But oh, the ground is directly connected to the LED strip. Just probably shouldn't have. Yeah, everything that's powering this device is a simple ESP32CE3 controller, which has built-in USB hub, programming board, I guess. So you just plug it in and just go. Yeah, very nice thingy. And we also have a magnetometer here, which is connected to accelerometer. And basic RGB strips. So these ones have light, well, white light too. So that's my battery. And that is my chip. Charging. Set up a switcheroo of the microphone so I would have more hands. The issue with this one, this design, it has no space for the controller input for some reason. Because if I take USB-C cable, I definitely had it somewhere. Take USB-C cable and try plugging it in. See the white part goes behind the plastic, which means I will need to have a bigger hole, likely. Yeah. I need some stretches. The print is starting. Okay. So I don't have very much in terms of clearance down here, but I think how it's going to work, I need to make a shape like this for this place, have mounting screws in here. That is the wrong part, mate. I thought I selected a different part, apparently not. Now it's the right part. If I print a mount, I would have a system here. If I get the button, which I can just cut everything off, I don't need it at the moment. It's very likely that I have too big of a button. Let's get in here and the button would be here. Yeah. So, oh no, it seems okay. Yes, just take out the USB-C cable, place the button in here. Okay, I do have enough clearance for a button, not that much, but should be enough. Well, at the end of the day, I can always just like print more things or make a hole bigger. Okay. So that is this. So let's actually build a mounting system. Sure. currently it does not have enough extension. So draw a sketch on this plane at the bottom. Say, hey, use this geometry and this geometry. Use this geometry. So we just draw a circle. This. Circle like this. We trim that circle. First, maybe check the dimensions of the clearance. Clearance. Might closer. Footprint clearance. I'm printing a box, a storage box. Sure my spool is holding correctly. That is the clearance. Now we trim the outer circle. And I need more clearance here. Just a simple line. And this in between these two should also be clearance. Okay. Great, the orientation will be ensured by the screws on the ends. And now I just extrude this thingy the opposite direction. And likely to the bigger distance. If the light fixture itself will be 20, so I guess also 20. We'll see, you can always just trim it down, which will help. And if I hide the tooth now, yeah, it's just a simple shape, a simple sliver, and that simple sliver would allow me to mount the battery and would have extra space to mount the sensors, which is, I think, enough to mount the sensors. They're very tiny. Oh yeah, I also need to mount the controller. Hopefully there is enough space. Box is being printed. Good. So, can hide the rail. Rail is not needed. I do need a show the sketch for the holes. Do I? No. I need a new sketch. On here. Say use is this view, and we use whole geometries. Use a hole, hide this, draw a circle in here, circle in here. And dimensions will be insert hole. Okay, that's a sketch. Now we can extrude. Remove as blind, yeah, it is blind. Good. See, it's a lot of very simple shapes, but the assembly is kinda messed up. Yeah. How to fit a square thing into a round hole? You print around their things. And that's extra space for the electronics. Still a button part, which I'm not sure how I'm going to do that yet fully. Because at first we need to print how we mount the charging port. I can just get a smaller button. But I don't have this kind of button. Yeah, the problem when the button is large, it's very satisfying button. It's like big toggles. But it also takes a lot of space. I don't have a smaller button. Okay, it's okay time. So that is how I mount the charging. Now I need to mount the electronics. So yeah. And once I mount the electronics, I can figure out how I combine the rail part with other parts. Probably is going to be very easy. It's a sandwich. Wait. Wait a minute. Oh no, that's not going to happen. The clearance here is maybe enough that I could cut out this part from the rail. Yeah, cut out this part from the rail and then use the hole in here. Oh wait, I cannot. A circuit will be in the way. Yeah, I cannot use it. Good. So that is the rail. I guess I need other parts. I really wish they had more I don't know what I'm trying to say. Oh, ESP controller would have a mounting hole. Like, sure, it's small, but there's no good way of mounting it. Can also have some layering. Some. let's just build parts. Camp. Or make another cap. Honestly, this part would be easier to make the other cap. Hello, cap. I did it. So we take cap. Can we duplicate it? Copy cap. Paste. Paste. Nope, that did not help. Copy part. Yes. Minus 3 and 8. Okay. We'll see if editing this cap would help in any way. I don't really have these mounting holes. I guess it will mess up electronics. Move probably. No, that's not M. I can't. I don't. Maybe we'll figure out that later. Hide it, and then let's create a new part. And surface, and sure, and this one. The surface, top, hide the rail. It's a square. Square. Center point square. Basically a tiny box called ESP controller. This one on the center. Distance. What's the size? It's quite small. Length. Very nice when you have a WLED installed. You can just update using Wi-Fi. 25. So that's this. So that's my W. That's ESP. Extrude. Fifth extrude, sure. New solid. It's quite small though. I think it's just like because my caliper. It's only 4 millimeters, and it has so much power. Can make a little tiny web server from it. What is this? Cancel. Rename battery. Rename name assembly. Name USB. I guess the issue with the mounting becomes difficult because I need access to the pins and it has no mounting holes, contrary to the Motion and Muse. They do have mounting holes, which makes it easier to use. New part. If I mounted my... We'll see. If I can fit the mounting holes in the center, it should be fine. If I cannot fit mounting holes in the center, that is problematic. And I need to increase the distance for the IMUs. Now the question is, do I mount it flat, or actually need to mount it like this? Oh, I know how can I do this. I think I can mount them vertically and maybe even save some space if I did the sandwich like this. Yeah, I can share the pins, which means easier soldering. And all of them uses the same mounting holes. Yes, yes. That's actually pretty good. So I would just need a single pillar. Oh look, the box has finished. Look at this cute box. Very strong. Very nice. Box. Okay. So, idea. Okay, that's more difficult. Sandwich. You may question why I'm saying sandwich, because I also need to make things printable, so... Okay. I have an idea. We did this. We did this. We draw this. Not this. I would say use this geometry. Use this geometry. Yeah. I'm getting hungry. Undo use. We move the box here. We resize the box. I only need 2 points to be mounted. Yeah. I need a circle. Yeah. A circle. Actually 2 circles. The circle should be the midpoint of this line. So make sure these circles, yep, they are correct. Distance between the circles. Inside of the circle would be a insert hole. Insert hole. Oh, I have plenty of space. Look at this. I hope you understand what I'm trying to do. It's quite simple. I say as I invent odd things. Mm-hmm. 30. Oh, it cannot be resolved. Why? Because this one is in the wrong location. It's our pet. What? Oh. Use this geometry. Use this geometry. Distance between these should be like, I don't know, 3 millimeters. That's enough. Yep. And then I can move this. Why is it doing this? Distance between this one and this one should be 8 or something. Distance between this one should be equals to this one, which I cannot reference the geometry. What? Lol. Oh, I know, it has a midpoint. Delete this. It has midpoint constraint. That's why it's behaving so oddly. See? Eight or whatever. 8, and distance between these two should be like also 8. That does not really matter much, because it's going to do one simple purpose: hold the thing. these should be 15. Less. Yeah, 15 because I need to have some clearance for screws. Or maybe 10. 12. Yeah. Now we extrude. Not this one. It's a new body. Oddly enough. Very simple. A new body. Make sure it does not impact the tube. Which it does not impact the tube. Good. What's the height of the accelerometer? The accelerometer is fine, it's smaller. Accelerometer is 20. So I'm definitely fine with 25. Probably make it 20. Nah, just leave it 25. So, you have a tube, hide the tube. Have this assembly. We have this assembly, and this assembly can screw into the bottom part, which is quite nice. I could also yes, I figured something out. Have this assembly have a bracket for the ESP controller. Yeah. So I can edit the sketch. Yeah, I add the bracket and it can hold the ESP controller. It's a double purpose assembly. That is the wrong square. Like this. Use this geometry and use this geometry. Dimensions of this one. What dimensions? This one and this one. Cool, Onshape disconnected. Thanks, Onshape. By the way, not sponsored. I have maker's license. Cool. Oh, cool. It's alive. Sir. And that is why having a web-based browser is kinda bad. Not browser. Modeling software. Sure, you can use anything everywhere, but once you can use everything and everywhere, it's unusable. 0.5. Actually, probably be 0.8 at least. A bit more clearance. Yeah. Then I do this and I do that, and we extrude. By, I don't know, this amount, make it 11. Wait, there's more. If I hide my ESP and then also extrude these things. Yeah, but wait, there's even more. We extrude these things from the offset. How starting offset? Depth will be this one. Nope. Depth 4 millimeters. And then it will be to this distance. Yep. Seven. Yeah, 7. And we have this tiny fancy bracket which will hold the controller. Now I need to combine these parts, so this one, and this one, and this one. Boolean union. See? A tiny bracket which will be mounting to the bottom. And then on the sides I will mount the controllers, or the IMUs. So let's build the mounting holes for this geometry too. This one will be opposite. Use this and this. Okay. And can I create a hole? Hide assembly, create a hole. This and this. Do we have the longer ones? Okay. 20? No, that's 18. I need to check. Screws? No. I have 20, but that's not enough. Can I rotate it? Yes. Wait, no. Start from selected plane. That's not a plane. Sure. Well, then just make it regular. Start from the part, rotate it. Does not use counterboard. The size of a hole is screw size. Of course, I cannot do that. 3.5. Okay. 3.5 enter. Okay. 2 beautiful holes. Would be nice to have the countersink or counter 4. Can I have it on the opposite side? Not really. So I need to make a tangent plane. Can I have a tangent plane to this? Look normal. To orient the plane. This. That is not a tangent plane. This. That's again not a tangent plane. What about this? That is a tangent plane, but that's the wrong location of it. Oh, good. That is a tangent plane. So we have a tangent plane, which is very difficult. Why I'm doing this? Because if I just... the screw will go into this direction. I can't do otherwise because I don't have that much longer of a screws. Could get longer, but I don't want to. And these needs to be larger to facilitate the head of the screw. So create a sketch on this plane. Let's say we use geometries. This one and this one. Create circles. And their sizes should be 6.1. Okay. Now we extrude. Right. I selected the plane. Extrude. Remove. Three. That is quite a bit, but I think that's manageable. Good. And it's still printable. Very printable. Well, this one can be also just printed. I'll be putting screws down. Okay. Look, assembly is getting there. Still quite a long things to do. And I'm getting at the point where it should probably, you know, stop. New sketch on the left. So take the accelerometer because it's the largest part. Yeah, and I guess it should be very simple thing. Use this geometry, make a circle. Its dimensions should be insert a hole. And the distance should be dimension point to point 4. Also 4. Yep. So put it by the screen and check the size. Very simple solution. Amazing simple solution. Extrude, remove this. Yep. Uses the same hole, easy to print, as it itself does not require much tolerance. Holds the SP controller, and just plop one sensor in here with the screw, and pop one sensor here with the screw. Or even better, uses, well, I cannot use the same screw. No, I would have two inserts. And additional point, as the sensors are very close, there is little to no wiring, and then they can also loop their own wire for I2C protocol. I guess the only thing is left, oh, there's two more things left. Power, which means USB-C port, power button. I don't think I'll be finishing that today. We'll have to do that next time. A cap. Yeah, a cap. And how to mount the rails. Because they do need to be fairly tough. Yeah, mounting it by two single points would probably be too little. Not like it can mount that much. Though rails. We look into the tube. My rails could go over. Yeah, like we have these sensors mounted. Sensors mounted. No idea. Honestly, no idea at the moment. But that would work. That still does not have an option how to mount it to the rail. And it's fairly neat. Eventually, this part can be smaller, charging part can be smaller, everything what's in here could probably fit in here. So it have slightly more space for the lights themselves. Or you know, you can always just mount these 2 points. It's so little. It's not enough points. Wait. I don't need to have that much. Why? Because the geometry will hold it. As it's roundish, it will not go away, so there will be now this force, only this force, which is tiny, and having a singular screw holding it probably is enough. Probably. We'll see. Yeah, I think I had enough for today. That's the stick. My other stick is this disassembled. We have the battery printed, some boxes printed for whatever. We have a tube. We have a cap printed for one side. Yeah, things will need to go later. Anyways, so yeah, that was engineering. Pretty good. Printing. Time to rest, I guess. So I would say bye for YouTube. So if you're interested to see more about what kind of stuff I do, just check out my videos or other live streams. Yeah.